Welcome back everybody to Desktop Inventions. Now I know it's been a while since I made a longer video, but I've been busy making 30 short videos in 30 days on 3D printing hacks. So if you haven't seen those, go check them out. So today we're going to be doing another 3D printing upgrade on the Ender 3 V2. Have some bed springs here, so we're going to be upgrading the bed springs. Should be a pretty simple and straightforward upgrade, so let's get to it. Alright, so now before we get to the upgrade, we have to ask the question, why are we doing this upgrade? What's the reason? And today I'll give you two reasons for this upgrade. So the first reason is, with these weaker springs right now, the bed is not that stable. If I grab it here and I shake it, I can see the platform's not that stable, and I'm afraid that that's going to lead to issues when printing at higher speeds. So reason number two would be, I've had it happen several times. Over time, as you do prints, some of the screws in the corners will loosen over time, and that'll cause, as you're printing, the nozzle to drag in some of the corners, and basically it'll mess up your bed leveling. So then if you have the BL Touch, you'll have to go and create a new bed mesh, or if you don't have BL Touch, you'll have to go and manually level the beds with the 4 corner screws. So I think when we get these stronger springs in there, we're going to solve both of those issues. And now getting into the upgrade, it's super easy. We're just going to take these bed screws and loosen them. We will turn them towards the up direction marked on the wheels. Once you do that, they'll just drop right off. There's 1, 2, and we've got this one in the back, 3, and number 4 in the back here. If you have the Ender 3 V2, this one has a bracket that holds the cable harnessing up. Now we're just going to take the bed and lift it off, and then we'll take our 4 springs out of here. And be careful not to put any stress on these wires here. This is for your bed heater and your bed temperature sensor. Now we can set this down. Alright, so I have the old springs here and the new springs. You can see a couple differences right away. So the new springs are taller. The new springs are about 26 millimeters tall, and the old ones are 20 millimeters tall. The diameter of the springs is the same, but the new springs are using thicker coils. And then if I try and compress them here, we can see the old springs are able to compress pretty easily, and the new springs are very strong. I'm barely able to compress these with 2 fingers. So you can take my word for it, but actually let's do some measurements and show just how much stronger these new springs are. To compare these 2 springs, we'll be calculating the spring constant, which is just the force it takes to compress the spring divided by the distance that you compressed it. So starting with the old spring, I'll be compressing this about 4.5 millimeters, and we'll use the scale here to measure the force. So at about 160 grams, that gives us a spring constant of 35 grams per millimeter. Now let's add a spacer and check that value again. For this type of spring, it should be constant, so we should get the same answer. This time we've compressed the spring by 6 millimeters, and we're getting about 220 grams as the force. That calculates out to 36 grams per millimeter, so we're right on par with the previous measurement. Now let's do that same measurement on the new spring. This time we'll be compressing it about 2.5 millimeters, and we got about 280 grams of force. So that calculates out to about 112 grams per millimeter. So let's add a spacer and double check the value. This time we compressed it by about 4 millimeters, and we have a force of about 480 grams. So that calculates out to 120 grams per millimeter. Pretty close to the previous measurement. So from that we can see the new springs are about 3 times as stiff as the original springs. So now before we install the new springs, I have to mention there's an almost free way to do this upgrade that doesn't involve new springs. It's a bit of a cheater method, but you can use an M4 nut and an M4 washer and get almost the same results. Let's take a look. So if we look at the bottom side of our bed here, we see this is the screw that's a little bit wobbly. So we can take an M4 nut and just thread that on all the way. If we tighten this down tight, that gets rid of the wobble there. And then we'll add a washer so that the spring has a flat surface to sit on. So now we'll be able to compress this spring another 3 millimeters, which will give us another 100 grams of force. And then we can tighten the springs down much more to make this a solid connection. So then the problem we might face is that the nozzle is too far away from the bed, and we can't lower it anymore because of our Z-stop. And luckily there's a solution for that too. So on the Ender 3 V2, there's this tab here that prevents the Z stop switch from going any lower, and all we have to do is cut that off. So now we can lower our Z-axis stop switch and tighten our bed springs that much more. Just make sure there's no other interference on your 3D printer before you do this. And now we can see here, even with the cheater solution, the bed doesn't have the left and right play anymore, and it's much more stiff than it was before. And now let's install the stronger springs. And again, the installation of those is pretty straightforward. Just slip the springs over the studs, line up the holes, and then tighten your nuts on there. And now we can see with the upgrade springs, this bed does not wobble back and forth at all, and it is extremely stiff. Now before you go off printing, make sure to reset your Z offset because it definitely has changed. Also, you'll have to re-level your bed. Here I'm using the Gyres firmware to do a 100-point bed leveling mesh. You can see the result of that here in this cool visual map. And as a way to measure the difference before and after the upgrade, going to be printing this tall, skinny stick here, and we'll be looking at the quality before and after the upgrade. Alright, we've got the stick print out here on the loose bed, and let's see how it turned out. Wait a second. Do you ever feel like you have those moments where there's a glitch in real life? Yeah, I just had one of those moments. So now let's look at the results here. I have the original on the left, and then the cheater spring in the middle, and then the upgraded bed springs on the right. Now for the first print here, I did make sure the bed springs were extra loose so we can maybe see the worst case results. And then we can see towards the top here, things did get a little bit shaky on this print. And now to look at the print with the cheater springs on it. Now this print here was overall a lot smoother, but we did have a little bit of layer shifting at the top as well. And finally, the print with the upgraded bed springs. Now this one overall looked like the best out of all three, and it was pretty smooth for the most part. But I couldn't help but notice something still wasn't right about this print. And now, welcome to my 3-day journey down this rabbit hole. When I put the calipers on this print and hold it up to the light, I can see the edges were not as smooth as I thought they were. And then I noticed when holding the print up to the light, I can see this strange pattern going down the length of the shaft. And when I measured that pattern, I saw it was a consistent 8.5mm spacing. So I set out to see what that could align with. So I moved my Z-axis by 8.5mm to see if I could see anything obvious there. And I noticed that was exactly 1 revolution on the stepper motor. Very suspicious. Since I recently installed the dual Z-axis upgrade kit, I decided to see if that was part of the problem. So I took the second Z-rod axis out of there and performed another test print. And to no surprise, the pattern was still there, and the quality of the print went down a little bit as well. So continuing on the path of troubleshooting, I thought maybe there was some binding in the original Z-axis rod, so I reinstalled the second Z-axis rod, and then I removed the first Z-axis rod and did a test print with that. Now this time the print quality was pretty bad, and when I held it up to the light, we still have this pattern. So now digging myself deeper into the hole, I thought maybe my voltage reference had a problem on the Z extruder. So I ended up digging into the printer, checking that, found it was 1.2 volts, and then I tried to turn that up to 1.375 volts and did a test print with that. And again, that test yielded me no results. Still thinking there was some type of binding in my Z-axis gantry, I tried another test by loosening the rollers on the gantry. And again, I struck out with that test. And a bunch more tests I tried that were unsuccessful were lowering the printing speed, lowering the flow rate, using a smaller layer height, using a larger layer height, and again I was continually striking out. And then finally I figured it out. In retrospect it seemed so obvious, but it ended up being a problem with the slicing software. I'd set the model to my default 20% infill, and it ended up giving a very weird infill pattern on this, where it was basically giving pockets of infill and pockets of empty space. And that infill was just thicker areas that we're seeing under the light, and also those infill areas caused some bulges on the prints. So I ended up printing again with 0% infill, and we got a super smooth model coming out of that. Now after all that work, I am printing the finest, completely useless vertical skinny rods that I've ever printed. And now to wrap up my thoughts on this upgrade, this spring upgrade is the cheapest and easiest upgrade I've ever done. Is there a huge benefit? Well, it's hard to say, but for the price and effort, I think it's hard to argue with. Now as you're looking to buy some of these kits on Amazon, some of them come with these red aluminum wheels, which in my opinion are just completely unnecessary, unless you like the look of them. But they will add weight to your build plate, and they don't work any better than the plastic wheels. Basically, people on Amazon are just bundling these together so they can stay above a minimum price. If you are going to buy a bundled kit, I would recommend getting one with an aluminum extruder, since the stock plastic extruders on the Ender 3 are notorious for breaking. And that's it for today's upgrade video. If you have any ideas for future upgrades, leave them in the comment section down below. And until then, we'll see you next time on Desktop Inventions.